In the last class, I was discussing polar coordinates, and then as an example of polar coordinates, we were solving uniform circular motion. In uniform circular motion, one more important aspect is there that is called as banking of rods. So I want to continue with this also, and then I will go to non-uniform circular motion. And after non-uniform circular motion, I will discuss questions of polar coordinates and circular motion. So basically, what is the meaning of banking of road? Suppose you are having a road track like this. It is having a curve. It is having a curvature like this, and a car is moving on it. Okay? A car is moving on it, and suppose here I'm looking at the car. So car is here. So car is basically here. Car is like this. This is the car here, and it is traveling in this direction. So basically, if this track is curved, then this car will undergo some type of circular motion. Try to understand, if this car is moving on this curved path, then it is undergoing circular motion. And if it is undergoing circular motion, there will be a need of the source of the centripetal force. So we are going to find out that source of the centripetal force and what restriction this source is placing on the speed of this car on which is running over here over this circular track. We are going to find out this one. So please write, suppose a car is moving on a circular track, then it will require a source of centripetal force. Then it will require a source of centripetal force. Try to understand.
Repeat from the start.
If a car is moving on a circular track or a curved track, if a car is moving on a circular track or curved track means road, then it will require a source of centripetal force. What that source will be, try to understand here. If you look at this car, its weight is going to act in the downward direction. Okay? This will be mg. Mg is the weight that is acting in the downward direction. And here, Earth is going to apply a normal reaction on it. It is very similar if you are placing a block here. Okay? Try to understand, if you are placing a block over a surface, weight of this block is going to act in the downward direction, that will be mg. And because this block and earth, they are in contact, so a contact force will be there. A reaction force, normal reaction will be exerted by the earth on this block in upward direction, and you call it as N or R. This is normal reaction here. So here in this case, car is not moving in the upward direction, so automatically this weight and this R, they are balancing each other. So what you are saying, that here this R is going to balance this mg. That's why this car is not moving in the upward direction. They are exactly balanced. So on car, a normal reaction is acting on the car. Its weight is acting downward. So both are equal and opposite. So they are balancing each other. So first equation will be this one. Now on the moving track, there will be a tendency. Try to understand, if this is a smooth surface. Suppose if you assume that this is a smooth surface and this car is moving like this, then you will find out that it will skid in the outward direction. So what I'm saying, this car is having a tendency. Car is having a tendency to skid in the outward direction. To skid in the outward direction. In the outward direction. And you can observe this type of example in the snowy season. On the hilly region, when snow is falling, then on the surface of the road, there will be a layer of the ice, and that will reduce the frictional force to the minimum. So the surface in that season, it will be more or less frictionless. And if you are running a car with a speed over this circular track, then you are going to find out that this car will skid in the outward direction. But in normal season, ठीक है ना, it is not skidding, it is not moving in this direction, it is having a tendency to move in this direction, but still it is not moving. So who is going to stop here? Who is going to stop here? That is actually the static friction force. So static friction force is acting in this direction between the tires and the earth. ठीक है ना? In between tire and earth, they are in contact with each other. So there will be a static friction force that is going to act in the inward direction. Inward direction means in the direction of radius of curvature. Its radius of curvature will be somewhere here. Or you can say this is center of curvature, you can say, and this is radius of curvature, R. R. So when car is traveling with a speed, then basically this static friction force that is going to stop this car in the skidding in the outward direction. But you know this static friction force, this is variable. You are aware that this static friction force is variable or self-adjusting. Variable or self-adjusting. Adjusting. What I'm saying by the meaning of variable or self-adjusting this static force, what I'm saying here, if you apply a force here in this direction, you apply some F force here, okay, and still it is this block is not moving. Even after applying this force, this block is at rest. This block remains at rest. Then who is stopping this block to move in the forward direction even after applying the force? That will be a static friction. That will be a static friction. So what I'm saying by the variable, if you are making this force 1 Newton, if you apply this force is suppose 1 Newton. I'm telling you, suppose this is 1 Newton, then this Fs, it will also be 1 Newton. If you make this force 3 Newton, 3 plus 1, 4 Newton. This will be 1 plus 3. Again, it will be 4 Newton. So whatever force you are going to apply, same static friction force, it will come into the picture automatically in the backward direction. This static friction force is opposing the possible motion, prospected motion. ठीक है ना? This static friction force is there. But there is a upper limit. This static friction force is having a upper limit, and you call it as, there is an upper limit. I can write here, there is an upper limit of static friction, and that is called as, क्या बोलते हो बेटा इसे? What you are going to call it? That is called as limiting friction. That is called as limiting friction. And you represent it by Fs maximum. Fs maximum. And its value, what will be the value of this Fx maximum? That will be mu s, coefficient of static friction, into the normal reaction, that is R here. So this is the value of maximum value of static friction. Try to understand up to the point this F is less than this Fs max. If this F is less than Fs max, the block will be at rest. The block will be at rest. Will be at rest. But the time at which, even up to this, if F is less than or exactly equal to Fs max, basically this block will be at rest. When F is becoming equal to Fs max, this block is ready to move, but it is not moving. It is ready to move. But the time when this force applied, it becomes greater than this Fs max. limiting friction, then block will start moving. Then block will start moving. Start moving. So basically what I'm trying to say, if you are having a block and this you want to make this block moving, then you have to apply a force that should be greater than the limiting friction Fs max. Same thing is applicable here. Basically this car, this car is undergoing this circular motion, some type of circular path it is following. So it needs, what it needs, it needs a centripetal force. And how much centripetal force will be there? That will be mv square upon r, where r is the radius of curvature. You can write here where r is the radius of curvature. Where r is the radius of curvature. तो r क्या है बेटा? Radius of curvature of this track. ठीक है ना, ये जो ट्रैक है इसका रेडियस ऑफ कर्वेचर है. सो नाउ this car is moving with a velocity v. Here I can write this was moving with a velocity v. So required, what is this? This is the required value of centripetal force. So who is going to provide this value? Who will become the source of this centripetal force? This static friction force. This is static friction force. So basically this centripetal force required for this circular motion, it will be provided by the static friction force. But problem is this static friction force is having a maximum value. So what I have to write here, for the circular motion of this car on this curved track, basically this mv square upon r, it should be less than or equal to Fs max. You can write here, for the circular motion on the curved path, please write for the circular motion, for the circular motion on this curved path by the car,
Please, sir, repeat.
for the circular motion, for the circular motion on this curved path by the car, it will require a source of centripetal force. It will require a source of centripetal force. It will require a source of centripetal force. Full stop. Full stop. Here, static friction force Fs. Here, static friction force. Here, static friction force between tires and the ground and the road. Here, static friction force between the tires and the road will act as a source of centripetal force. Will act as a source.
Can, can you repeat
Will
from when
act
here
as a
static
source.
friction force between
Here, please write here, static friction force between tires and the road. Here, static friction force between tires and road will act as a source. Of centripetal force. Full stop. However, there is an upper limit of static frictional force. However, there is an upper limit of static frictional force. Called limiting friction. called limiting friction, Fs max equal to mu SR, called
Limiting.
limiting friction. Here I have written limiting friction, called limiting friction. Next, in the next line, you can write Fs max equal to mu S into R. Mu S into R. Mu S into R. ठीक है? It means, full stop, it means for no skidding, it means for no skidding, for no skidding, centripetal force mv square upon r, required centripetal force for no skidding, comma, the required centripetal force mv square upon r, should be less than or equal to, Fs max, and Fs max is equal to mu s times r, and r is equal to mg. So it will be like this. So what you are writing mv square upon r. It should be less than mu s mg. M is going to cancel out, and this v should be less than or equal to mu s gr. Mu s gr. So v should be less than, so car should travel, if you don't want that the car should skid, then this car should move with a speed less than this square root of mu s gr. Likho beta, please write. This is the upper limit of the speed of car. This is the upper limit. This is the upper limit of the speed of the car. This is the upper limit of the speed of the car. Full stop. If car moves with a velocity, greater than, square root of mu s gr, if car moves with a velocity greater than mu s gr, then static friction force, if car moves with a velocity greater than square root of mu s gr, then static friction force will not be sufficient, then static friction force will not be sufficient to provide, required centripetal force for the circular motion. Will not be sufficient to provide required centripetal force for the circular motion. And car will skid. In the outward direction. Full stop. Please write in the next line. This problem can be solved. This problem can be solved by banking of curved tracks. This problem can be solved by banking of curved tracks on the outward sides. On the outward sides. In this type, in the outward sides, beta. Okay. On this side, its height will be, this is the road here, road is here. Okay. On this side, it will be a little bit higher as compared to inner side. And this angle is supposed theta. This process of making road in the outward direction a little bit higher and on the inner side a little bit lower, this is called as banking of road. This is called as banking of road. And what will be the effect of this? Suppose a car is moving here. Suppose a car is moving here like this. Okay? Then try to understand its weight still, it is vertically downward direction. Weight of this is going to act in the vertically downward direction. This will be mg. And can you tell me what will the direction of the reaction of this road on this car? Okay? It is like a ramp or this type of track. If you place an object here, what will the direction of normal reaction? Normal reaction are always perpendicular to the contact surface. So here, this is the contact surface. So normal will be perpendicular to this. Normal reaction, it will be like this. Like this. So here, this will be the direction of normal reaction. It will be like this. Perpendicular to the road. Okay? So if I draw this angle, if I draw this direction here, just here, I draw this horizontal direction like this, and this is vertical direction. I'm saying this is the vertical direction. So this is vertical direction, this is horizontal direction. And what is this? This is R. This is R. So now what will happen? If this angle is theta, then here this will be theta, this will be 90 minus theta, and this angle will again be theta. So here try to understand this angle. This will be theta, this is theta, this is theta, this is 90 minus theta. So this will again be theta. So this will be theta. Now you can resolve this R into two components. So ये जो R है, you can resolve this R into two components. One component will be here. This will be R sine theta. And what will the direction of this? This is in radially inward direction. So this direction will be actually, I have not made this diagram very clear. Okay, so this will be here. Here, there will be center of curvature. Somewhere here, you are going to have center of curvature. I just try to make it more clear to you. Just 1 second. So here, this road will be something like this. Something like this type of curved track we are talking about. So here, radius of curvature will be there. This will be R. Okay, and here, this will be. Or I can say this as N. If you want, if you are confusing with the normal reaction, this and radius of curvature, then I can write it as N. This may be N. This will be N. Here in this direction, this will be N cos theta. N cos theta. So now this weight of this car, that is mg, it will be balanced by this component of normal reaction N cos theta, that is going to exactly balance this mg. And this component of normal reaction N sine theta, that is acting toward the center of curvature, this N sine theta, this is going to act as a source of centripetal force. By banking this road, you have removed the dependency of the centripetal force on the friction force. Now source of the centripetal force is not the static friction. But who is the source? Now a component of the normal reaction. So by making this banking here, you are creating a new source of the centripetal force, and this will be mv square upon r. Now divide these two equations, n will be cancelled out, and you are going to get tan theta. Tan theta, and this will be v, m will be cancelled out, and it will be equal to v square upon rg. So you get this equation. What this equation is going to tell me? Tell me that okay.
Sir,
For yes, beta, please.
sir, can you please explain the n sin theta is equals to mv square upon r?
देखो बेटा, this component of this is normal reaction, normal to this inclined plane. This is perpendicular to this like this. So I can resolve it here in two directions. One will be horizontal direction and one will be vertical direction. Here you can understand in a much better way. This is theta, try to understand. Then automatically this will be theta. This angle will be 90 minus theta and this will be theta. So this will be r cos theta, and this will be r sin theta. And if you look at weight mg of this block that is acting. So similarly here, the weight of this car is balanced by this n cos theta. So I'm writing n cos theta equal to mg like this. And this component here, this component, this is acting toward the center. Throughout this circular path, this component will be in the direction of the center. So this has all the requirements. ठीक है ना? It fulfill all the requirements to act as a source of centripetal force. So this n sin theta, it will behave as mv square upon r, or the source of the centripetal force.
Sir,
So
this is the
basically by
equation of
banking of the
bending of
road,
rods.
you are creating a new artificial source for the centripetal force. Yes, beta, please.
This is the equation of bending of rods.
Yes, banking of roads. This is the equation for banking of roads. How you use this in designing the roads? Actually, there will be an upper limit. For all the hilly areas where curved paths are there or anywhere, okay, there will be an upper limit. On all the curved paths, you will find out an upper limit for the car. Okay, upper limit will be there. Suppose that upper limit, you are saying this is upper limit V UP. Okay, this is, I write it as just, I'm writing this is the V max. That is a better word. V max. Suppose you want, this is the upper limit on the speed of the car. So I will substitute that V max here. I will substitute V max here. Radius of curvature I am known, is known to me, and this G will be there. G will be there. So I can easily find out tan theta. Tan theta. So by substituting V max here, I will find out this theta. And on the basis of this theta, we are going to bank this road. When they are designing this road, this theta will be corresponding to this equation. And this n sin theta, now it is not depending upon the friction. It is not depending upon the friction. Okay? So basically here, for this upper limit, this banking of road is going to act very good. Car is not going to skid. Okay? Please write here. Here, from this equation, one can find out. From this equation, one can find out the angle of inclination. From this equation, one can find out the angle of inclination. One can find out the angle of inclination for the banking of road.
Oh, the angle.
Inclination. Angle of inclination. Inclination for the banking of road. For the banking of road corresponding to the upper limit. Corresponding to the upper limit. Corresponding to the upper limit. Full stop. For this type of banked road, for this type of bank road, if velocity is less than upper limit, if velocity, speed, if speed is
Sir, repeat.
for this type of banked road, if speed of the car, if speed of the car is less than, if speed of the car is less than upper limit, then no skidding will take place. 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 Full stop. Please write in the next line. Even if velocity becomes greater than upper limit, even if velocity becomes greater than upper limit, then even if speed is greater than the upper limit, comma, the car will not skid. The car will not skid in this case. The car will not skid in this case because static friction,
So please repeat the sentence.
even if speed of the car,
From if
Even
even if
if-
velocity becomes
please
greater
write,
than
even if speed of the car becomes greater than the upper limit,
Sir,
car will not skid.
sorry, sir. Even if velocity becomes greater than or speed greater,
It will be speed, beta. Sometimes I said this word velocity, but this is speed. Even if speed is greater than upper limit, comma, car will not skid because static friction force between tires and road,
Sir, please, धीरे धीरे.
because static friction force between tires and road comes for the rescue. ठीक है, so what I am saying, ठीक है ना, in some
sir,
cases
comes for the
rescue comes for the rescue. So what I'm saying that if suppose velocity is greater than upper limit, so this will be the required centripetal force.
Line force between tires and road will.
I don't know. Actually, I'm not.
Last 3 words, sir.
Then static friction force between tires and the road will come for rescue. ठीक है, so what I am saying, if suppose
Thank you, sir.
somehow V is greater than V max. ठीक है, so this is a special case. If V is, suppose, let us assume V becomes greater than V max, then try to understand this n sine theta. N sine theta will automatically less than this. So basically, it is not sufficient. This component of normal reaction is not sufficient to provide the required centripetal force. Then what will happen? It should skid in the outward direction, but it doesn't happen. Why? Because this Fs ठीक है, this Fs is coming for the rescue. So what it will be in that case, if this V is greater than Vx, then this mv square upon r, it will be provided by n sine theta, a part by this component, and plus a component of Fs in this direction. So I can write this Fs here. This Fs, and this angle is also theta, so this will be Fs cos theta. And this will be plus Fs cos theta. It will become like this. Full stop. इसके बाद लिखो, in this way car will not skid. In this way car will not skid.
Sir, you write the equation. Write this equation.
Pardon? It is not visible.
Okay, sir.
So
Yes,
basically here in this direction, centripetal force, ठीक है ना, is required. How much centripetal force is required? This much amount of centripetal force is required. But this n sine theta, it can provide only corresponding to Vmax. So it is not sufficient. It is n sine theta. This is less as compared to this because V is greater than Vmax.
After this equation, R
After?
will not. After
I
this
am not,
equation, sir, mv square divided by r equals to n sine theta plus fs.
Fs cos theta. N sine theta plus Fs cos theta. This will be the equation.
So
Yes, beta, please.
why this Fs cos theta is not in tan theta equation?
Why this Fs cos theta? Because we don't want to dependent upon the friction. Because what is the problem? Because in mountain areas, ठीक है ना, snowy weather will be there. So many times you will find out a situation when this surface will become slippery and friction force will be very less. So we don't want to dependent upon that. So what we have done, we have created an upper limit. Okay, you are not going to drive your car with a speed greater than Vmax. We applied this limit and we calculated this theta. So corresponding to this theta, static friction force is not needed, only this n sine theta. It will be sufficient. It will be sufficient to provide required centripetal force. ठीक है? But somehow many people are there, different type के बंदे हमेशा होते हैं, ठीक है? If they are traveling even a little bit greater than that upper limit, then this will be for rescue if it is present. If snowy weather is there, then it will not be there. It will be negligible. It will be, ठीक है? That's why.
So theta is designed in such a way that only normal reaction force will act like.
Yes. ठीक है? This component of the normal force, now totally this is artificial. This is artificial centripetal force source you are creating by banking this road. ठीक है? So this is called as banking of roads. ठीक है? This is called as banking of roads. Now, next, non-uniform circular motion. Next is non-uniform circular motion. Okay.
Sir, if theta is greater,
Theta is always designed for ठीक है ना, for a particular upper limit. ठीक है ना, और ऐसा नहीं है you can create a theta as you can just continue to increase it. Otherwise, ठीक है ना, some other forces. Try to understand if you make it very high. Try to understand on the next page I can show you. What is his question is, he is saying that if you make this angle of inclination quite large, if you are doing this, then you are creating a problem. Why you are creating a problem? Suppose this is your car, its weight is here. Try to understand. This weight is here, mg is here, and this will be theta. So in this direction, a component of weight will act, that will be mg sine theta. If you make this theta quite large, then due to a component of its weight, it will have a acceleration in this direction. Okay? Okay? It will have an acceleration in the static friction force will be there here. And try to understand, if you make this component very strong, if you make this theta quite large, then what will happen? This car or this block will have a tendency to move in this direction. It will have a tendency to have an acceleration in this direction. And in that case, this static friction force or friction force, it will start acting in this direction also. So there are some other problems are there. So that's why upper limit is created.
Sir, basically, Fs cos theta balance the centripetal force.
Not balance the centripetal force. Fs here.
Sometimes the speed is greater than.
No, it's not balancing. They are themselves acting toward the center. So how they can balance? They are the source. They can only act as a source to the centripetal force. They are not balancing. No one is going to balance the centripetal force for the circular motion. Try to understand. ठीक है ना? Fs sin theta. Okay, this Fs sin theta, in that case it is going to be here. ठीक है ना? This and this n cos theta, it is going to balance this mg plus Fs sin theta. So that will also come into the picture.
Sir, in second case, n sin theta plus Fs cos theta is also upper limit.
But why you are going into so much detail? I don't want to go into the mechanics. ठीक है ना? Surely everything is having upper limit. I have shown you this situation. ठीक है? If you are getting this where the diagram is gone, suppose you start increasing this angle, then when this angle will become greater than angle of friction, sorry, angle of क्या बोलते हैं उसे? Angle of some not friction. I forget that name. Okay? If that angle is becoming greater than this g sin theta, it will start dominating, it will start moving like this. So there is a upper limit. Many factors are there. But why banking of roads are there? I have only discussed that part. So when you are designing a road, not only this factor, but other factors are also there. Okay? So upper limit will always be there. Okay? Upper limit will always be there. If you are having, you continue to increase the speed, there will be a time surely you are going to skid. Okay? So there is nothing like that. You can move with a very large speed. No. Surely there will be an upper point somewhere, even in this case also. After that, your car will skid. Okay? So car will skid. Upper limit will surely be there. Now, next is non-uniform circular motion. Non-uniform circular motion. Non-uniform circular motion. Non-uniform circular motion are those in which speed of the particle undergoing circular motion changes. So here, non-uniform circular motion means speed of the particle ठीक है, undergoing circular motion changes. Undergoing circular motion changes. Why it is changing? Why it is changing? In the uniform circular motion, there was only one force. There was only one force. That was centripetal force. So in the last case, try to understand, we were discussing uniform circular motion. When particle was undergoing uniform circular motion, you should be very clear about this. Just 1 second. This is the center here. And suppose here is your particle. It is undergoing uniform circular motion. Try to understand its velocity at that moment was here. This was Vt. where was the force? One force was here. And this force, this was responsible for this circular motion, uniform circular motion. So what is the angle between them? Angle between them is 90 degree. There was a second force also. If you consider, then there is a vertically downward direction. Vertically downward. So I'm saying this is the vertical direction, Z direction. So try to understand there will be a vertically downward force, its weight. But remember this angle between this horizontal velocity, because this is horizontal circular motion. So angle between this horizontal velocity and the vertically downward, this will also be 90 degrees. So this can also, this mg, it cannot change. It cannot change the speed of this particle because two forces are there. One is centripetal force, another is this weight. Both are perpendicular to this horizontal velocity. Horizontal velocity. So that's why this was uniform circular motion. Now we want to study non-uniform circular motion where speed of the particle is changing. Why it is changing? First question is why it is changing. So I'm removing this now. And I'm considering the vertical circular motion here. Example of this is vertical. Its best example is vertical circular motion.
Sir, simple harmonic motion.
Not simple harmonic motion. Simple harmonic motion is a very small part of the circular motion. You are correct in that extent. But like you have seen, वो मेले में देखा है ना, जब मेले में जाते हैं, then there will be a ऐसे जो क्या बोलते हैं उन्हें, जो झूले होते हैं, पता नहीं what you will
Yes, sir.
say, ठीक है ना, that type of thing, vertical circular motion. This is the best example of this non-uniform circular motion. So here I'm talking about vertical circular motion. So this is vertical plane. This is a two-dimensional motion and this is vertical. Now try to understand. This is the center. This is the center. Okay? Here. Now, second is you are saying this is tangential velocity Vt, and you are saying this is not constant. This is changing. Why it is changing? I am coming to that. This is not constant. Constant. Vt will be how much? This will be r omega. Vt, that will be r omega. Okay? So that is not constant. So you are saying this, that Vt, that will be r omega. This is not constant. R is constant. Radius is not going to change. So here, omega, or you call it as theta dot, this is not constant. So what I'm saying here, that this speed of the particle that is undergoing circular motion, speed of this particle, that will not be constant, as well as angular velocity, this will not be constant. So both tangential velocity and angular velocity, angular tangential speed, you can say magnitude wise, I am saying, so velocity will also change, its magnitude or speed, and this angular velocity, they will not be constant here. They are going to change. But question is why they are changing. So look here. Suppose this is the particle at this position. Its velocity will be here. This is the tangential velocity. This is Vt. This is Vt. Here, this is the direction of centripetal force. Okay? So this and this, they are perpendicular. Both are perpendicular. Okay? And this is in vertical. The circular motion is taking place in the vertical plane. So try to understand its weight is going to act in the downward direction. This will be mg. This will be mg. Now look here, a component of this mg will be in the opposite direction of this Vt. So here, I assume that this is θ1. I don't know what it is. So this is θ1, suppose. So a component of this will be here. mg sine mg cos θ1. This will be mg cos θ1. So what you are saying, you are observing here, particle is moving in this direction. This is the velocity. And a force is acting opposite to its velocity. So here this is velocity, and opposite to the velocity there is a force. So this is a opposing force. So what type of motion will be there? Retarding motion will be there. So from here, this is the vertical line. Then try to understand when particle is moving in this direction, here in this half of this vertical or circular motion, this opposing force will be there. This is a opposing force. Try to understand. So there will be a retarding, there will be a retardation here. So this will be a zone of retardation. Zone of retardation means its speed is going to decrease. It will be maximum here, and it is going to decrease here. If you look at here, if you look this situation here, then this will be the tangential velocity. This will be, its weight will be here. Weight will be here, mg. So surely a component will be opposite to this, and I call it as θ2. So this will be Vt here. So automatically this will be mg cos θ2. So throughout this half, you are going to find out that a component of the weight is always acting opposite to the velocity. So weight is opposing this motion in the upward direction in this half of the journey. So that's why in this region, in this half, speed is going to decrease. So this is a retardation zone. This is a retardation zone, speed is going to decrease. ठीक है ना? This is retardation zone, speed is going to decrease. But if you look this particle here after this point, then its velocity will be here. This will be the tangential velocity Vt. Its weight will be here. Its weight will be here mg. I call this angle θ3. And look here, this mg will have a component parallel to this. So this will be mg cos θ3. So in this second half, basically a component of the weight will act in the direction of the velocity. So that's why speed is going to increase. Here, speed is going to increase. So due to the component of this weight in this zone, throughout this zone, you can choose anywhere. Anywhere. Suppose this is the Vt. Vt. Weight will be in the downward direction, mg. So this angle is θ4 again. So a component will be here, that will be mg cos θ4. θ4. So in this second half, in this half circle path part, basically a component of the weight is acting parallel to the velocity. That's why speed is increasing. In this zone, speed is decreasing. Speed is increasing. Speed is increasing in this zone. And this is accelerating zone. What you say it? This is accelerating zone in case of non-uniform circular motion. Here this is retardation zone, and here speed is decreasing. Speed is decreasing. Decreasing. So what is happening here in case of vertical circular motion? Velocity of the particle is making an angle with the weight mg. As a result, there will be a component of this weight either parallel to the velocity or anti-parallel to the velocity. If the component of mg is parallel to the velocity, it will increase the speed. Acceleration zone will be there. And if the component of mg is becoming anti-parallel to the velocity direction, then it is going to retard the motion. Speed is going to decrease. So due to this mg throughout its motion, this mg is at some angle with this vt. ठीक है, except this point. नहीं, इधर भी ठीक है, इधर भी एंगल पे होगा. Here it will be like this, here mg will be there. ठीक है, only at this point it will be 90, and at this point here, at these 2 points, weight will be at 90 degree. Other than these 2 points, at every point you will have a component. ठीक है ना, you will have a component of the weight either parallel to the velocity or anti-parallel to the velocity. So particle will undergo either acceleration or deceleration or retardation. So that's why speed of the particle continuously changing if particle is undergoing vertical circular motion. And because speed is changing, so we call that type of circular motion as non-uniform circular motion. We call that type of motion as non-uniform circular motion, beta. So today I am stopping here. In the next class, first I will complete this and then I will start discussing questions, beta. Okay, beta. Thank you very much. Good night.
Thank you, sir.
Good night, sir.
Welcome, beta.
Good night.
Good night, beta.